Hello everyone, welcome to the mechanical engineering mashup. So in this video we are going to uh, discuss about the thermodynamic system. So what is exactly thermodynamic system? So it is a region in a space enclosed in a boundary whose behavior is to be investigated when undergoes through a thermodynamic process. So generally thermodynamic means we study about the conversion of heat into the required work output. So in that condition, during the conversion process we need a particular system or any object which should be undergone through a thermodynamic process, that is the taking the heat as an energy and giving the output, that is the work, which may be electrical, mechanical or any chemical energy for a required application. So for that purpose we have to know about the thermodynamic system which undergoes a thermodynamic process to get the required output. So it is defined like this: it is a region in a space enclosed in a boundary whose behavior is to be investigated when it undergoes through a thermodynamic process. So now again another definition we can give for the thermodynamics means it is also defined as a macro, not microscopic, macroscopic volume with its boundaries and surroundings, and it undergoes a thermodynamic process according to the thermodynamic principle. So that means it is a system, means it is a region or a space or a particular body or a particular object which is having a boundary and surroundings around it, and it undergoes through a thermodynamic process according to the thermodynamic principle, okay, for getting the required work output. Okay, so this is again like this also we can define the thermodynamic system. So next I am giving the example. So this is a body shape I have selected. So this is an example for a system which is having certain boundary, and around it is surroundings. The boundary will separate the system from its surroundings. Similarly here, a cylinder, a piston is given. So inside the cylinder a system is taking place, that is air. So here the air is the system which is enclosed by the cylinder and the piston. Okay na? So this air undergoes through a particular thermodynamic process for getting the required output for the required application. So these are the two general examples we can take for a thermodynamic system. Okay na? Next we go for about the thermodynamic system. So about means it is enclosed by its boundary. So that means it will have certain boundary which can separate it from its surroundings. And next it's so same point, its boundary separates it from its surroundings. So system is enclosed by the boundary, and that boundary separates the system from its surroundings. And next, the boundary of the system may be fixed or imaginary and rigid or flexible. So that means here we are saying that the system will have a boundary, and that boundary will separate it from its surroundings also. Okay, and again that boundary may be fixed or imaginary. So and again it may be rigid or flexible. So how can we define means? Fixed boundary means there will be no change in the boundary. That means there will be no change in the shape of the system. Okay, that is considered as a fixed boundary. And imaginary means here when you take this body, so the if you take air as a system, the air is entering into this body and leaving through this inlet. So this is inlet and outlet, consider it is as inlet and outlet. The air enters into this system and leaves this system to the outlet. So that means it don't have any particular uh, fixed boundary. Here the air is the system, so the air is entering and leaving. That means it won't have a particular fixed boundary. So by drawing these two imaginary lines, we can assume it is as a system, the air inside this body as a system. So that is referred as the imaginary boundary for the air system inside a particular body. So next, it may be fixed, it may be rigid or flexible. Rigid means again the boundary should be fixed, and flexible means always the boundary of the system should vary. So again here, whenever the piston reciprocates inside the cylinder, the air enters and leaves. So that means here the boundary of the system always changes, entering and exiting. So the boundary may takes place from inlet to the outlet. Otherwise, when the piston remains constant, the air will be inside the cylinder only. So again in that case also it can have particular boundary for the air inside the cylinder, that is the system. So that means flexible means the boundary will be continuously vary for the system. So that is about the rigid and fixed, sorry, flexible boundary and next fixed and imaginary boundary. So next we go for classification of thermodynamic systems. So there are mainly three types of thermodynamic systems. One is closed system, second one is open system, and third one is isolated system. Okay na? So what is closed system? So the closed system means which contains a fixed quantity of matter. Which contains fixed quantity of matter. It means no mass transfer takes place across the boundary, but energy transfer takes place across the boundary of the system. So it means here it is a system which has a fixed mass, and there is no change in the mass takes place during the uh, thermodynamic process. Okay, but energy transfer takes place from the system. Okay, the mass of the system is constant, but the energy transfer takes place from the mass of the system across the boundary of the system. So here I am taking one example, that is air inside the closed cylinder. Air inside the cylinder closed by the piston. Okay, so here I am taking the air inside the cylinder closed by the piston. Okay, so I am taking the hot body. So the mass of the air is constant. Okay, air, even it is expanding or contracting, the mass remains constant, but the energy transfer takes place to the system. So from hot body, if you consider air is cold, so from hot body to the air, the energy transfer takes place, but the mass is remaining constant for the air. So this is an example we can consider for the closed system. So remember again, in a closed system, the mass will be constant, but the energy transfer takes place across the boundary of the system, from the boundary of the system. Okay, closed means mass constant, but the energy is not constant. The energy transfer takes place from the system. So that is closed system. So next thing is open system. So open system is one which allows the transfer of both mass and energy across the boundary of the system. Okay, so this is opposite to the closed system. So in this open system, the transfer of mass as well as energy takes place. So example, I am taking a steam of a particular mass entering and leaving the turbine through the nozzle. So okay, assume this is the turbine and this is an impeller. Okay na? So here, or runner, this is a runner, so the steam is entering through the nozzle and leaving through the exit. Okay na? So the mass is not constant here. So even the flow rate may be constant or may not be constant. So that's why here the varying mass of the steam is entering and leaving. At the same time, the energy transfer also takes place. That energy is one is kinetic energy of the steam and another one is the mechanical energy of the runner here. So that means it is entering and leaving. The mass is changing continuously when it is entering through the inlet of the turbine and leaving through the nozzle of the turbine. Okay, so this is an example for an open system where both mass and energy transfer takes place across the boundary of the system. Okay, so next is isolated system. So it is completely opposite to the open and closed system. Here it won't allow any transfer of mass and energy both. It won't allow the transfer of mass and energy both. So that means it remains isolated from all the effects. That means it remains unaffected by anything when it undergoes any thermodynamic process. So it is hypothetical in the universe. It cannot exist in the universe. So when you take this is as an isolated system, it won't get any effect by the thermodynamic process. Okay, so it is completely isolated from all its surroundings, and the temperature changes and its property changes. That means it becomes completely stable. The properties won't change. The properties remains constant every time. Okay, that is called as an isolated system. So this is about the thermodynamic system. This is the basic for discussing about the various laws of thermodynamics and various processes in thermodynamics. Okay, I hope you understand about the thermodynamic system. And once again, thanks for watching my video. And if you still have not subscribed to my channel, please subscribe to my channel. Please encourage my videos. And once again, thanks for watching my video. Thank you all.